Hey guys, so today I'm just going to be kind of making a quick video basically explaining kind of what the difference is between a coroutine and using the update function in Unity. I have a very basic scene lined out here. I have one script that uses the update function, and then I have another script that uses the coroutine IEnumerator functions. So I'm just kind of going to go over in some detail a little bit about why it might be better to use a coroutine, for example, in this case. Um, but I'll basically run each code. So for the first thing I'm going to do, I just have a basic scene set up here. I have a directional light, the default one that comes with. I have my flicker update, script here, and basically we'll just go over what's going on in here. So I just have something that takes in a light component. I have the interval at how fast the light's going to flicker, and then I have a timer. So basically what we have going on here is we have a timer that's essentially equal to delta time. Now, what is delta time? Well, delta time is basically the amount of time that passes between frames. So essentially what you're looking for here is a quick thing about every PC is going to be kind of different. Someone might have a $3,000 computer and someone might be running it on a $500 laptop. The main concept of this is that you want the time between frames to pass equally between each computer. So you don't want someone to have a very fast computer. Someone moving at 100 units on their fast computer would be astronomically faster than somebody who's playing on a laptop who might only move 10 units in a second. So the idea for this is just to move time equally among all devices wherever you're using it, so that it's scalable, and that way it's easier for everyone else. Um, Here we have, if our timer is less than our interval, we just basically check whether the lights are enabled or disabled. We do the opposite, and then we just reset the timer and then just display a debug log based on if the light flickered. And same thing kind of happens here in the coroutine script. We'll just kind of go over what's going on here. So same kind of thing, takes in a light component, has an interval basically for 0.5, so that's how many seconds I want it to wait. You can make this any number you want. If my light's not equal to anything, we start the coroutine, and basically this while loop will always be true, and we're going to essentially do the same thing we did in the update script, but in this case we're going to do a yield return wait for seconds interval, so that will be 0.5 seconds. Once that seconds timer has hit, we're going to basically start again by printing the debug log the light flickered. It's going to loop true and just keep doing this every 0.5 of a second. Now, the main reason I wanted to show why it might be more beneficial to use a coroutine is Unity always runs update functions on every object in the game, even if the update function is blank. So even if you're not using the update, it's still going to run, and it's going to take up like power on your CPU, and it's just not going to be the most efficient way to do large scale projects. But in this case, it doesn't matter. I'm just showing that you can essentially do the same thing with a coroutine that you can with an update, and it achieves the same result. So basically what we'll do is we'll run the update function first. So this is what it looks like with an update, and basically you're just going to see it flicker. It's going to print the debug log, and that's every 0.5 of a second. You can make this bigger, do 1.5, and run it again, and you see it takes longer, and again, and so on. So we'll disable this one really quick, go to the coroutine test, and we'll do the same thing. We'll run it, and the same thing happens every 0.5 a second, because in my interval here I have 0.5 seconds, and if I wanted to change that number, that would basically be the same thing. So I could just stop this, flip it to 1.5, and it should work the same way. And there you go. So yeah, it can be done the same way. I always like using coroutines in my projects whenever I do anything. When I've worked with companies before, they've always been much bigger fans of using coroutines because it's just more friendly to the computer, and it saves like a lot more CPU power basically when you're doing something much larger scale than this. So it's just always a good practice to get into using this type of code if you can. And yeah, that's pretty much it. Thanks for watching.